algebra students, Mr. Lawrence here, and this is your second video on sequences. First, let me start by reading the problem on the board. Some of you took attempt at on Thursday in class. Betty is learning to assemble toys on an assembly line. As she gets more practice, she becomes faster. Her first shift, she is only able to assemble 2 toys. Her second shift, she is able to assemble 5, third shift 10, fourth shift 17, and her fifth shift 26. Write a function that can be used to describe this sequence. Use your function to predict how many toys she will assemble during her 10th shift and her 40th shift. By the way, as in our functional notation, this last part here, we'd be looking for f of 10, right, after you know your function, and we'd also be looking for f of 40, where we actually put 40 into the function machine. Now, some of you know how to do this. Derek Katrubes came in Thursday morning before class, looked at it, knew what to do. Derek, don't tell anybody. Look, if you just tell your classmates how to do it, you're cheating them of the chance of learning how to do it, and then they're not going to be able to do it on a test. So you think you're helping them, and yeah, they might get a couple points for homework or something, but they're going to fail a test, and that's where the real points are gained. All right. Now, I'm not going to talk any more about this problem, but I'd love to see some of you bring this in to me Tuesday. All right? In fact, I'd love to see all of you bring this in to me. But let's talk about our sequences, our f of x, and we've got first set of data, second set of data, third set of data, and our inputs are 1, 2, 3, 4, 5, and our outputs are 6, 13, 20, etc. We're going to go looking for the nth term. Yeah, the nth term. So let's see if we can find the nth term. All right, and then we'll be able to write our function. Now, we knew that we should find our first differences from the other video. And let's see, this would be plus 7, and this would be plus 7. And, ooh, it looks like plus 7 is repeating over and over and over again. That means that my nth term is going to be something like 7n. So I'm going to take my input, put them in to n's position. So I'm going to do 7 times 1, 7 times 2, 7 times 3. So I'll do that. Oops, silly me. Sorry about that. 21, 28, 35. Now I compare them, the blue line to the black line, the n line to the output line, the f of x line. And I notice that I'm 1 too many. Yeah, 1 too many. So I have to subtract 1. 14 into 13. On the second piece of data, I am 1 too high. I have to subtract 1. It looks like my n line, my 7, 14, 21 line is consistently 1 too many. So my nth term would be 7n take away 1. Because for the fifth piece of input, I'm getting 35. I should be getting 34. Oh, if I subtract 1, I get the number I'm supposed to get. Therefore, my function, my f of x, function, f of x, is going to equal 7x minus 1. Now, you might be wondering why I change variables. Well, because I'm putting x values in. I think of n as a number. True, it is variable, but I think of it as a number I just haven't counted to yet. You know, I'm going to count 1, 2, 3, all the way up to maybe like n. But the number coming before n will be n minus 1, right? And the number before that would be n minus 2. Okay, the number after n would be n plus 1 and n plus 2. And then, of course, I can count forever. So n I'm thinking of as a number, but the function is where the variable, the x, is coming in. Now, by the way, what kind of function is this? Well, it's linear, right? It's a linear function. How do we know? Well, the exponent on x is 1, right? The highest exponent on the variable or on the x term is 1. All right, now I can use this function to find any term I want in the sequence. So, for example, if I wanted to find f of 200, well, I'd put 200 into my function machine, which means I would go 7 times 200 minus 1. Well, 7 times 200 is 1,400, and then that would be 1,399. Okay, there you go. Now, I'd like you to try this one. I'm just going to throw a loop at you. Some of you will be confused by it, but go ahead and pause the video and try it. You should not still have the video running unless you've already tried it. Okay, here it comes. I'm going to find my first differences, and I notice that I need to add 3. I need to add 5. Here I need to add 7, and then I need to add 9. Ooh, that bothers me because in the last problem, the first differences were all the same. This one they're not. But if I go down to the second differences, right, these are called the second differences. Second differences. Wow, they are all the same. But when I'm on the second level, what do you think is going to happen? Well, it means that I'm going to need to change my exponent. These, when I go to look for the nth term, they're not going to be n to the first power, they're going to be n to the second power. And so I can put my comparison line here, and I'm going to put 1 in for n, and 2 in for n, and 3 in for n, and really you should be using parentheses, but since none of my input is negative, it won't matter. If it was negative, it would matter. So n squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And now I compare, and look at this. My green ones are exactly too high, too high, then higher than my black ones. They're too many. I have to subtract 2 from the green to get that, to get the black sequence. So therefore, this is n squared, take away 2, which makes my function f of x equal to x squared minus 2. Now that I know that, I can find any piece of data in the sequence. If the input is 7,652, I can plug it in here and figure it out. Now that one's kind of big. I'm not going to do that one. Let's do, let's say f of, well, I should keep that in parentheses. I'll leave that blank here. Okay, and let's see, what number should we do? How about we do, say, 30. Okay, f of 30. So I do my order of operations. I have to square 30, and I'm going to get 900 minus 2, and then I'm going to get 898. So the 30th piece of data is 898. I don't know about you, but I'd rather do it this way than try to list out the first 29 pieces of data and then figure out the 30th. Seems so much easier. Okay, here's another one. I would love for you to pause the video. It's not a request, it's an order. Pause the video, try this one on your own. If you're still watching and you haven't tried it on your own, please pause the video. All right, here comes my solution. I'm going to find my first differences, and it looks like plus 3, plus 5, plus 7, plus 9. Ooh, that means the second differences are all going to be plus 2, and this is going to be a quadratic pattern. So I'm going to have something like n squared. I don't know if my nth term will be n squared, but it might be. Now, by the way, this 2 here and this exponent of 2 are coincidence. The reason that it's the second power is because the second differences are constant or consistent. Okay, not because there's a 2 here. All right, I believe on quadratics you always get a plus 2. When you do cubics, you always get a plus 6. And I think quartics, which is 4th degree, remember, that would be plus 24. I'm pretty sure about that. But it has nothing to do with this 2 and this 2. It has everything to do with the second difference. All right, so I know the first 5 perfect squares are what? 1, 4, 9, 16, and 25. And then I'm going to compare up, and it looks like I have to add 3. Yep, I'm adding 3 every time. 9 plus 12. Okay, now you don't have to check all 5. If you check 3 of them, you're pretty good. You're pretty good. If you check 4 of them, it'll be impeccable. You'll never be wrong, or maybe not never, but maybe never in a high school math class. That's a good way to say it. Okay, so my nth term is going to be n squared plus 3, because remember these greenish blue lines here, numbers were 3 less than the black ones, than my output I wanted. So I have to add 3 to my output. Okay, so my function, f of x, is going to equal x squared plus 3. Okay, so now if I want to find a value, and I don't know what you want me to put in for x, it doesn't really matter, although some of the numbers get way too big. I don't know, I guess I could go, say, with 35. Okay, so f of 35, well, 35 squared is 1,225. If you remember my trick for squaring two-digit numbers that end in 5, you'll understand how I got that so fast. And if I add 3 to that, I get 1,228. So that would be the 35th term. The 35th output would be 1,228. All right, here's one more. Again, please go ahead and pause the video. If you're still watching and you haven't tried it on your own, please pause the video and try this on your own. You're cheating yourself if you just sit and watch it like you're watching a bad TV show. All right, first I'm going to find my first differences. Plus 7. Oh, what is that? Plus 19? Yeah, that's different. What is that? 65, 28. 68 must be 40. Right, 68 minus 28 would be 40. So this is only 65, so it's going to be 37. Okay, and then 126 minus 65, I think is going to be 61, right? Wow, that's really different. I haven't seen one like that in the videos, or I haven't shown one like that, I should say. I've seen it, but it's new to you. So I found my first differences. Now I'm going to find my second differences. And it doesn't look like they're going to match, does it? Plus 12, plus 18, nope, they're not matching. Plus 24, yeah. All right, let's go down to the third differences and see what happens. Oh, plus 6 and plus 6. Look at that, the third differences are matching. Oh, what do you think is going to happen with the nth term? Well, if the first difference is matched and n was raised to the first power, the second difference is matched, n was raised to the second power. If the third difference is matched, do you think n will be raised to the third power? Let's try it. Now, there's a lot more writing here. I'm going to erase it. I don't want you to ever erase your work. That's good work. I'm only doing it for clarity so you can see what I'm doing. So I put my comparison line in here. Okay, now I'm going to cube my inputs. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. And now I'll compare. How do I turn 1 into 2? I add 1. 8 into 9, I add 1. 27 to 28, I add 1. It looks like I'm adding 1 every time. Therefore, my nth term is going to be n cubed plus 1. My function, therefore, becomes f of x equals x cubed plus 1. And one more time, I can put any number I want into this function. So I can do this. Parentheses are a smart idea if there's a negative. Now, it looks like all my inputs are positive, but they don't have to be. And I'm going to plug in, this time I will plug in, say, I don't know, how about 40? Okay, I'll put 40 in there. And let's see here. 40 cubed, I know 4 cubed is 64, and times 10 times 10 times 10, I think it's going to be 64,000, right? 40 times 40 would be 1600, and then times another 40. Yeah, I'm pretty sure that's right. Then if I add 1, I'm going to get 64,001. Hold on one second, ladies and gentlemen. I am looking for something. I'm just all of a sudden having a moment of doubt about that. 64,001. I just want to make sure I'm doing it right so I'm not thinking the wrong thing. Yep, I'm good. Okay. Just grabbed a calculator to check myself. I don't like to let the calculator think for me, but I always like to use it to check. All right, so here's your video quiz. You need to find the nth term. You need to tell me the function, and you really should tell me what type of function it is. Is it linear? Right? Is it quadratic? Is it cubic? All right, could even be quartic if I went to the fourth power. give you a hint. I didn't give you enough data for you to be able to identify a quartic. So it's going to be one of those three right now. And then find, for number 1, find f of 400, and for number 2, find f of 35. All right, Mr. Lawrence signing off. I hope you enjoy your long weekend. Have a good night, everybody.